Problems 1 and 2 are very similar to the same problems that were on your quiz. We just went over these, I think, yesterday, right? So for numbers 1 and 2, they ask the same exact questions in the same exact order as your quiz. So for number 1, it wants the vertex. In this case, this is your vertex. It is at the coordinate 0, 1. Over 0, up 1. The axis of symmetry, that has to do with the x value of your vertex. I'm going to warn you, once again, I will be picky on this. I had people on their quiz just put 0. The axis of symmetry is an actual line, so that's why you have to have x equals the x value of your vertex. You have to have the x equals. I can't stress it enough. Then it wants to know, is this vertex a maximum or a minimum? This is the very highest point on your graph, so this is a maximum. Domain, for all of these, the domain has not changed. So the domain is always going to be negative infinity to positive infinity. It goes that, we don't know how far left it goes, we don't know how far right it goes. That's what the domain is. The range is the only time that you actually use that y value of your vertex. Everything else has to do with the x values. So for the range, you're going to write how low does it go, comma, how high does it go. So how far down does our graph go? We're not sure, negative infinity. And how high does your graph go? It goes up to 1. So the range is the only time that you use that y value. The increasing and decreasing intervals have to do with the x values. Some people mess those up on your quizzes, so we've got to make sure we fix that for your test. So increasing interval is asking where is your graph increasing in regards to x values. So it's increasing right here, and it starts increasing, we don't know, so negative infinity. And it increases until we get to here, which on the x-axis is 0. Don't put 1. It has to do with the x value of that vertex. And then decreases, it starts decreasing at that vertex, which the x value is 0. And it keeps decreasing, we don't know, so it goes on forever with infinity. Any questions? Because decreasing, these have to do with x's and y's. I'm not worried about going down because that's on the, these are both x's. Going down is a y value. It's decreasing over to this side forever. It's going this way forever and ever and ever. Nope. We just quizzed over them. I went over it yesterday. We've gone over these 15 million times. It's literally the same thing over and over and over again. All right, number 2. The vertex for number 2 is right here. Shh, please stop talking. The vertex is right here. This is a coordinate of -1, -1. The axis of symmetry is always x equals the x value of your vertex. And once again, you have to have x equals. This is the very lowest point on your graph, so that means that this is a minimum. Domain, how far left, how far right, we don't know. So that's why it's negative infinity to positive infinity, because the graph would continue to get wider, wider, and wider forever. The range is how low does it go, comma, how high does it go. So, and this range is the only thing that has to do with the y values. So how low does it go? It starts here at -1. Comma, how high does it go? We don't know how high it goes, so we say infinity. Increasing intervals, increasing and decreasing, you're looking at the x-axis. So you are going to be including positive and negative infinity, and then that -1 value from your vertex. So increasing, it starts increasing right here on the x-axis, -1. So it starts increasing at -1 and it continues to increase. We don't know when it stops. And it's going to the right, which is a positive infinity. Decreasing, it starts decreasing somewhere over here on the left, which left is negative. So negative infinity. And it keeps decreasing until it gets to here at -1. So one way to also think, for those who are looking at this one up here, still a little confused as to why it's the positive and negative infinity. So where it says increasing interval, it starts increasing somewhere over here on the left. X values are left and right, so how far left does it start increasing? We don't know. So that's where you think of it. On the left is negative, and since we don't know where it starts increasing, it's negative infinity. And it keeps increasing until we get here. For decreasing, it starts decreasing at 0, and it continues decreasing to the right, because again, x's are left and right. So if we don't know when it stops decreasing to the right, that's why it's positive infinity. Yeah.
So how is it negative infinity on the number 2 decreasing, because it comes from the top?
So it starts up here because these are x values. So how far left does it start decreasing? We don't know, right? We don't know when it starts decreasing. We don't have a specific point, right?
Yeah, but it's up in the positive.
But on the x-axis, it's somewhere over here where it starts decreasing, but we don't know where on the x-axis. So if it's off to the left, that's negative infinity. And if it's off to the right, that's positive infinity. That's why this is positive. Does that make sense?
Yeah.
Left is negative infinity, right is positive infinity. You might want to make a little note to yourself with that. All right, 3, when you are ordering these from widest to narrowest, widest is actually going to be the smallest, narrowest is actually going to be the largest. So you're going to list these in order from smallest to largest. So you'd have y equals 3x squared. That's your first one. That's going to be the widest parabola. Y equals 4x squared is kind of in the middle. And y equals 5x squared is the narrowest. It's going to be the one that's closest to the y-axis if we were to graph these.
You have to put y-axis for all.
No. I think that'll be a multiple choice one tomorrow. All right, any questions on the front page? It's basically the same thing as your quiz so far. So is this page.
I've got all these right so far.
Good. It's our 5th time doing it.
Except for increasing it.
Okay, well hopefully my extra little explanation there made sense. Number 4, what steps transform the graph? What that's asking is how does this translate? So if you see x plus 3 inside the parentheses, that means left 3. Minus 5 outside the parentheses means down 5. So a couple of other people, they saw the 2, so that meant that it made it narrower. They also saw that it was positive, so it opens up. We don't really need to get that far into it. The 2 lets you know that this is actually going to get narrower because it's like, but you don't need to worry about that. If it were a negative, that would be a reflection or it'd be like pointing down. All right, 5, 6, 7, they're asking the same exact thing as number 4. For number 5, because this minus 5 is not inside parentheses, that means it would move down 5. For number 6, because the minus 2 is inside parentheses, that would mean it moves right 2. And number 7, inside the parentheses says plus 3, so that would be left 3. Outside the parentheses says plus 4, so that would be up 4. That's it. Number 8 is the very last thing that would be very similar to, yes?
For 5 through 7, can we just write like the point, like the vertex point, or do you want
You can, but I think these are going to be multiple choice. So as long as you know how it moves. Okay, yeah.
What's number 4 then?
Number 4 is left 3, down 5. Okay? Number 8, in order to write the vertex, you have to know how this moves. So if you see plus 2 inside, that means that it moves left 2. And if you see minus 4 on the outside, that means down 4. When you write your vertex, you need to write it from how it translates, not from the equation. Left 2, down 4 has a vertex then of negative 2, negative 4. If you have a vertex of negative 2, negative 4, that means your axis of symmetry is going to be x equals the x value of that vertex. So those are the 2 things we're looking for there. Any questions? Okay, now we're kind of to the new, harder, maybe stuff. So you really need to pay attention. 9 and 10 wants you to look at the tables and figure out what type of data is in the table. Is it linear? You know it's linear when the pattern is using addition or subtraction. Quadratic, that's when the pattern, if there's like a pattern of the patterns, or it just doesn't even look like a pattern. Or you know something's exponential when the pattern is using multiplication. So linear, again, is addition or subtraction. Exponential is when the pattern is using multiplication. And then quadratic is when you have a pattern of the patterns. So basically, if it's not one of these, it's going to be quadratic. So for number 9, if you have 1.6 to 3.2, and 3.2 to 6.4, 6.4 to 12.8, and then 12.8 to 25.6. How are we getting from one number to the next, Allie? What is it? Timesing by 2 every single time. So if we are multiplying by 2 every single time, that means that this is exponential. Any questions? Okay, number 10. Again, same thing. Linear is when you use addition or subtraction. Quadratics when it's not that. Or exponential is when you use multiplication.
So quadratic would be like division.
Huh?
Or
Quadratic's going to look funky.
division.
It's just going to be like you'd have like a 1 and then a 5 and then a 7. It's just the number. They don't, like, you're not going to be able to see a pattern. So I would try linear, try exponential. If neither one of those work, then it's got to be the other stuff. So like for number 10, to go from -1 to -1.5, -1.5 to -2, -2 to -2.5, and -2.5 to -3, what are we doing every single time? Yep, so adding 0.5 or subtracting 0.5. Go ahead. I hope you know what you're doing. So each time you are subtracting 0.5, shh, quiet please. So because you are subtracting 0.5 every single time, that means that this is a linear function. Any questions there? Okay, here comes the really hard part.
Whoa, wait. I thought you said the plus was.
Plus or minus. Okay. All right, the rest of these, you have to write equations. So I have written up on the board these equations that you're going to have to write. If it's linear, you're going to write y equals mx plus b. If it's exponential, you're going to do y equals a times b to the x. And then quadratic, depending on what, it's all going to be dependent on what the vertex is. I put a generic equation up there, but you're just going to need to use the vertex to help you out with that. So if you take a look at this data or this example right here, we first need to figure out, is it linear, exponential, or quadratic? So didn't we already do this one? Yeah, we did one. We already did this one on the previous page, and we found out that this was exponential because the pattern was timesing by 2. So if it's exponential, that means you're going to write your equation y equals a times b to the x. A is going to be your starting value, and b is your pattern. So the starting value is always when x is 0. So in our case here, our starting value is 1.6. So we have y equals 1.6 parentheses. What's the pattern? Times 2 to the x power, and that's what your equation would be. That's it. You don't need to plug anything in. We didn't really have to do any math. That's it.
So
Leave it.
what does the x have to do with it?
That's just, it shows that it's an exponential equation.
So there would never be something like
No.
there.
Nope. Number,
Use the first one?
what?
Why'd you circle?
Because the 1.6 is the initial value.
Are we ever gonna, on this test, are we gonna have to write a quadratic equation?
Not from a table.
And then.
But we,
From a graph. You look at number 14.
yeah, I didn't know.
I know, I'm not there yet.
And then you put whatever you.
Okay, number 12. Number 12, first thing you have to do for these is figure out what type of a data this is. Please stop talking. To go from 3 to 6.5, 6.5 to 10, 10 to 13.5, and then 13.5 to 17, the pattern is that every single time you are adding 3.5. So because the pattern is using addition, that means that this is linear. The linear equation is y equals mx plus b. M is the slope. That's going to be the pattern. So m is the pattern using addition or subtraction. And then b is your starting value. Stop talking. So our pattern in this case is what we found right here, 3.5. So we have y equals 3.5x, and then our starting value is going to be what? 3. It's always when x is 0, so that's your starting value. So plus 3, and that's it. Leave it alone. Move on. Any questions? Okay, 13, 14, and 15. You're basically doing the same exact thing that you did up above, but now you're going to be writing equations from graphs, which is a little bit more difficult in some ways. So for 13, there's two parts here. For 13, is this graph linear, quadratic, or exponential? Exponential. This is an exponential graph. We just had a whole unit on exponentials. Well, this is a line, so this is linear. And this is a quadratic because it's a parabola. And exponentials are slightly, like slowly increasing. Yeah, look at that. All right, so exponential equations, again, are of the form y equals a times b to the x. A is the initial value. So if you look at your graph, where are we starting? What's the y-intercept? The initial value is starting value is the 1. Then you have to figure out what the pattern is. With an exponential graph, that's a little bit more difficult if they don't give you coordinates. So this point right here is 0, 1. This point right here is 1, 2. And this point right here is 2, 4. So when you're trying to figure out the patterns, you take a look at the y values. So if you go from 1 to 2 to 4, what is the pattern? Multiplying by 2. So that's why it's 1 times 2 to the x. Initial, 1 is the y-intercept right here. 2, the pattern, that's the pattern to get from 1 to 2 to 4. Mm-hmm.
That part's
Okay, 14, huh?
the curve starts as the initial value.
Yep, this is your A value. And then the pattern is your B.
Oh, I see. I'm good.
Okay. 14, anytime you have a U or an upside down U, I'm not going to get through this.
I just don't know how to
I'm working on it.
memorize all the.
You don't have to memorize all those.
Oh.
Yes. This is a quadratic because it's an upside down U. Because it's upside down, that's your red flag that there's a negative out in front. So anytime they are opening down, that means that it's negative. When you are writing your equations for these quadratics, you have to figure out how it translated. How did your vertex move? So this vertex moved left 3, up 9. So left 3, up 9. Now, how you write in an equation left 3, up 9 is a little bit different. So if it's moving left 3, that goes inside the parentheses with x, but how do I write inside the parentheses with x? Plus 3 squared. We're doing the same thing that we did basically right here. But it's on a graph. Up 9 goes outside the parentheses, but how do I write that? I do write that when it's plus 9. And that's it. Because it's outside. And then the last one is number 15. This is linear. This one you should be golden on because you've been doing these for like a million years. You write these equations as y equals mx plus b. B is your starting point. M is your slope. To find the slope, you need 2 good points. So here's a good point. Here's a good point. You do rise over run. Rise 2, run 1. 2 over 1 is 2. Put the X. And then B is your y-intercept, which is 1. And that's it.
Dang, I'm good. Keep going.
I do have